Hello everyone, good afternoon. This is Divya working as assistant professor in AAA department at St. Peter's Engineering College. Today I want to discuss about the solar resources which belongs to the subject wshe, wind solar hybrid energy systems. So, in this topic, I want to discuss mainly on three contents. Those are introduction, solar radiation spectra, and solar geometry. Coming to the introduction, the solar energy is the energy obtained by capturing the heat and light from the sun. So, energy from the sun is referred to as solar energy. And the technology has provided a number of ways to utilize the abundant resource. It is considered a green technology because it does not emit greenhouse gases, and solar energy is abundantly available and has been utilized since long both as electricity and as a source of heat also. The solar technology can be broadly classified in two ways. Those are active solar and the passive solar. Active solar is nothing but this is a technique include the use of photovoltaic systems, concentrated solar power and solar water heating to harness the energy. Active solar is directly consumed in activities such as drying clothes and warming of air. So, coming to the passive solar technique includes orienting a building to the sun, selecting materials with favorable thermal mass or light disappearing properties, and designing spaces that naturally circulate the air. And next, coming to the solar radiation spectrum. Solar radiation is the radiant energy from the sun. That means it can be also called as it is a electromagnetic energy which is delivered by the sun. It provides a light and heat for the earth and energy for photosynthesis purpose. And this radiant energy is necessary for the metabolism of the environment and its inhabitants also. There are three relevant bands, or those can be also called as ranges, along the solar radiation spectrum. Those are classified as ultraviolet, visible, and infrared. Of the light that reaches its surface, infrared radiations makes up to 49.4% of the, while visible light provides 42.3%, and ultraviolet radiation makes up just over 8% of the total solar radiation. Each of these bands has a different impact on the environment. Here you can see on the y-axis I represented the spectral irradiance, that is in wavelength omega meter square per micrometer, and this is wavelength in nanometers. So here you can see that this is the outside the atmosphere and this is the sea level and this is the visible light. So this diagram shows the solar radiation that reaches earth is made up of visible and infrared light. So only a small amount of ultraviolet radiation reaches the surface. The amount and intensity of the solar radiation that a location or body of water receives depends on the variety of the factors. For example, these factors may include latitude, season, and time of the day, cloud cover, and altitude. Not all the radiations emitted from the sun reaches the Earth's surface. Much of it be absorbed, reflected, or scattered in the atmosphere only. At the surface, solar energy can be absorbed directly from the sun, called the direct radiation, or from the light that has been scattered as it enters the atmosphere, and these are called as indirect radiation. So, we can measure the solar radiation also by using the wavelength cycles or measured in nanometers, that is in nanometer from peak to peak. The shorter the wavelength, the more energy it has. Blue light has more energy than the red light, and solar radiation is measured in wavelength or frequency. As light travels in a wave, a wavelength is defined as the distance from peak to peak and is measured in nanometers. Frequency is defined as the wavelength cycles per second and is expressed in hertz. Bands with shorter wavelength produced higher frequencies, and bands with lower frequencies produce higher wavelength. So this can be called as vice versa. The energy of the wavelength increases with the frequency and decreases with the size of the wavelength. In other words, shorter wavelengths are more energetic than the longer wavelengths. This means that ultraviolet radiation is more energetic than infrared radiation. Due to this extra energy, shorter wavelengths tend to cause more harm than the longer wavelengths. The more energy a wavelength has, the easier it is to disrupt the molecule and absorb it. Ultraviolet light can cause damage to DNA and other important cellular structures also. So, the solar radiation is finally classified into three bands, that is, three ranges, that is, ultraviolet and infrared and visible. This is about solar radiation spectra. And next, coming to the solar geometry, the solar geometry can be given by two ways, that is earth sun angles, and the second one is observer sun angles. Coming to the earth angles, these are classified into three types, that is declination angle, which is represented by delta, and the second one is angle of latitude, which is represented by phi, and the third one is hour angle, which is represented by omega. Coming to the first one, that is declination angle, which is represented by delta, it can be defined as the angle between a line extending from the center of the sun to the center of the earth and the projection of the line upon the earth's equatorial plane. That means here I considered the sun and here I considered the earth. This is the angle between the line extending from the center of the sun to the center of the earth. That means this is the center of the sun and this is the center of the earth. I am joining a line from the center of the sun to the center of the earth. Now the angle made by this line with the projection of the line upon the earth's equatorial. Earth's equatorial is the, this is the earth's equatorial. This line indicates the earth's equatorial. I consider only left side part. This total line indicates the earth's equatorial. So the angle made by this center joining line with the earth's equatorial is called as declination angle. So the declination angle can be defined as, this is the angle between a line extending from the center of the sun to the center of the earth, and the projection of this line upon the earth's equatorial plane is called declination angle, and it is represented by delta. And next, coming to the angle of latitude, which is represented by phi, it is a vertical angle between the line joining that point of location. That means this is the point of location I considered here, and to the center of the earth and its projection on the equatorial plane. Here what I done, I consider a point here and I made a projection to the center of the earth. So from this projection again I made a projection, or else I can say in other way, here I considered a point. So from this point I projected that line on the earth's equatorial, that is this one. So from this line again I projected that line here. So I joined this point with the center of the earth. So now the angle between the P to O, that means the point which I consider to the center of the earth, and this is the projected line. This angle is called as angle of latitude, and it can be defined as, it is a vertical angle between the line joining that the point of location to the center of the earth and its projection on the equatorial plane. That means this is the point of location to the center of the earth and its projection on the equatorial plane. Its projection on the equatorial plane. This angle represents the angle of altitude. And next, coming to the hour angle, it is represented by omega, and it is defined as the angle representing the position of the sun with respect to clock hour and with reference to sun's position at 12 noon. If, for example, I consider this axis as 12 noon, and this is the forenoon section and this is the afternoon section. So when we are going to the right hand side, this is 9 hour, that means solar time, that is morning for forenoon 9 o'clock, and this is 6 o'clock forenoon. And coming to the left side, this is 15 hours, that means afternoon 3 o'clock, and this is 18 hours, evening 6 o'clock. So here between these two lines, this is the 9 hours, that means forenoon 9 hours. The angle between this line and this line is 45 degrees. So here the hour angle is 45 degrees between the morning 9 o'clock and afternoon 12 o'clock. So this is called as our angle. Again I am saying the definition. We can define the hour angle as the angle representing the position of the sun with respect to clock hour and with reference to the sun's position at 12 noon. Here we are saying with reference to the sun position at 12 noon. So with reference to this, we are saying the hour angle. So it can be defined as the angle representing the position of the sun with respect to clock hour and with reference to the sun's position at 12 noon. And next, coming to the sun angles, here the sun angles are given in three ways. Those are altitude, zenith angle, and solar azimuth angle. The altitude is indicated with the letter alpha, and zenith angle is indicated by theta z symbol, and solar azimuth angle can be indicated by gamma s. So here I consider a normal surface, a horizontal surface. This is the sun. So here the sun rays are entering like this on that surface. This is the center of the surface, and I consider the direction on the surface, that is north, south, east, west, like that. So here the altitude angle, or else it is also called as inclination angle, the angle between the sun rays and its projection on the horizontal surface is called as altitude angle. That means if here I consider the sun like this is the projection line from the sun to the center of the surface. This is the main line, which is the connecting line from the center of the sun to the center of the surface. The projection line is the opposite to this one. We have to consider the horizontal axis. We have to project this line. So here I considered this line. Now the angle between the sun rays and its projection on the horizontal surface. That means here this is the angle. This angle is called as altitude angle, and it is indicated by alpha. And next, coming to the zenith angle. So here I'm explaining about zenith angle. Zenith angle is represented by theta z, and it is defined as the angle between the sun ray and perpendicular to the horizontal plane is called as zenith angle. That means again I considered the sun here, and this is the surface which I considered. So here this is the center of the surface. The sun rays means this is the sun ray which is in coming to the center point of the surface, and this is the vertical plane, that means perpendicular plane. Now the angle between the sun ray and perpendicular plane is called as zenith angle, that is represented by theta z, or else sometimes it can be represented with z also. So here this z represents the zenith angle. And next, that is the third one, solar azimuth angle. Solar azimuth angle can be defined as the angle of horizontal planes between the line due to the south and the north. The projection of the sun rays on the horizontal plane is called as solar azimuth angle. That means here I considered this as the sun. In the last two points, two concepts, I considered the sun on the left side of the plane, but here for the understanding purpose I consider the sun on this side. So if this is the sun ray, then I considered the projection, then the angle which is made by the horizontal planes between the line due to south and the projection of the sun rays on the horizontal plane is called as azimuth angle. That means this is the south plane. From this point to this point, if I consider, this one represents the azimuth angle. This is about the sun angles and earth angles. Thank you.